Okay, I'm going to show you how to run an independent t-test in SPSS. And the example I'm going to use is looking at gender and gender differences in course interest, computer comfort, and hours per day. You see the labels here, course interest. I'll spread this out, computer comfort, and then hours per day on the laptop. So before I do this, I just want you to note, I'm going to click on values, that there are two values. You can only do an independent t-test with two distinct groups. In this case, they are distinct groups. They're males and females. They're independent groups. There's a male group and there's a female group. All right? Male is 1, female is 2 in this case, and that's important, and I'll show you why in a second. So what do we have to do? Well, for any analysis, we go to Analyze. In this case, we're going to compare means, the means of males and females. So compare means, and then it's an independent sample t-test. Males and females are two distinct samples. So I'm going to click on that, and the first thing I'm going to do is click my grouping variable, which is gender. Those are the two. I'm going to compare two groups. So I'm going to go to define groups because it's saying question mark, question mark. It wants numbers. Well, what numbers does it want? It wants those numbers that I put in. 1 for male, 2 for a female. I'm going to do that, and then I'm going to send course interest, computer comfort, and hours per day. And I'm going to click on OK. And there's this output. So let's take a look at it. Maybe a little overwhelming at first, but we'll break it down for you. So you have course interest, computer comfort, and hours per day. We have males and females in each of these, 52 males, 100 females, and that seems to vary here. There's 53 and 101, 52 and 98. Depends on how much data somebody entered in. Perhaps a couple of females here didn't enter the data, or a male didn't enter the data in these two cases. So then we move along. We have the mean, 3.35 here, and 3.19, 3.77, 3.47, 7.78, 7.76. Even visually, that looks really close, doesn't it? And then we have the standard deviation. All right, and that's actually important, the spread of values. Because when we go down to this chart here, we have the results of our analysis. And so let's see what that says here. Well, the first thing we want to look at is Levine's test for equality of variances. Variance is another word, well, it's an indication of standard deviation. In fact, it's standard deviation squared. And so let's take a look here. It's asking, is this sample the same kind of spread as this sample? Well, according to this course interest, it's saying it's 0.05. Well, that's around the mark or right on the mark. Technically, I guess we could say it's not less than 0.05, so we could say those variances are equal. But if we want to be conservative, we can say equal variances are not assumed, and we can follow that line there, all right, instead of this line. In this case, computer comfort, it's saying the variances, which is 0.46 here and 0.87, they're actually different. They're significantly different. And therefore, we have to assume that equal variances are not assumed here. And we follow this line here. Okay? And then, in hours per day on the laptop, you see 0.692. Well, we can assume that equal variances are assumed. Variance, again, is just another word, I don't want to get too complicated here, for standard deviation or spread. So we have to make a decision whether we assume there's equal variances or whether they're not equal variances. So let's assume that there's not equal variances here. Then we move along here. We have a t-score of 1.25. And then we're just going to move over here, and the significance is 0.21. The significance here is the p-value. All right. Well, that p-value is less than 0.0, is greater than 0.05, and so 0.21 is clearly greater than 0.05. So we assume that males and females do not differ. Okay, this value is too large. Let's go down to computer comfort. Well, they're not equal variances, so I'm going to move along here. 2.8 is my t-value, and then it's 0.005. Wow, that is less than 0.05. So we can assume then, because it's so small, the chances are these differences between males and females are significant. So what does that mean? Well, let's take a look over here with males at 3.7 and females at 3.8 if I round off, and 3.5. So in this scale, we can assume that males are more comfortable with computers than females. This is the group that we looked at, are significantly more comfortable. Let's look at hours per day on the laptop. When we go along here, very small t-value, 0.03. Not surprising because we have 7.7 or 7.8 and 7.8. It's essentially the same. Look at that p-value, 0.97. That's so high. That's way above 0.07. So we can assume that males and females spend the same amount of time on their laptops during the day. Or another way of saying is males and females do not differ significantly. All right? So what we're looking at is these p-values. All right? It says sig, but those are p-values. And we have to decide whether to look at this upper one, which is equal variance is assumed, or equal variance is not assumed. So we look at, first of all, we look here and it says 0.05. It's really, really close. So I'm going to be more conservative and assume that equal variances are not assumed. So that's how you read an independent, run and read an independent t-test. Again, let's just go through it because it would kind of analyze, compare means, independent t-test. We go down here and we define our groups. It's 1, 2, so 1, 2. That's our groups. Males are 1, females are 2. And then we bring over our variables and we click on OK. We get these. We see our means. We can eyeball them. We can use these statistics nicely to describe the males and females. And then we take a look here and we see whether there's equal variances, and we decide. If this value is really, really low, we assume we follow the bottom line here. If this value is high, like 0.692 or above 0.05, then we assume that the variances are equal, and we just go along that line. And we take a look at the t-test, the t-value. Usually if it's 2.5, 2.3 high, then that's high. T, by the way, is just described the bell curve. That's a type of bell curve. And then we look at this p-value. I know it's labeled sig there, but that's the p-value. And that's the critical thing that we want to take a look at here. And when it's less than 0.05, we've got something going there. All right, so that is an independent t-test in SPSS.